Hello everyone, welcome to the Tensorflow tutorial about the RNN. And last time we looked at about the RNN as a classifier, and this one we're going to look at the Tensorflow as a regressor. So the data that we use for today is showing in here. Just let me plot it out. So that is the sequence that we want to predict. The red one is the result and the blue one is the sequence. So we want to predict the red one that based on the blue one over here. So both of them are sequence, and the red one sequence is the result sequence, and the blue one sequence is the sequence that we're going to base on this to predict the red one. So let's ignore this first. So let's just times 10 because this is the time steps. So we shrink the time step by 10 of the size. So let me just comment this out. So before we start this tutorial, you must, if you don't know what is RNN, just check out the links in my description. That is the Google's tutorial about RNN, this quick introduction about RNN. And for this script, you have to make sure you will run these scripts on the TensorFlow. The version of TensorFlow is there are 0.110. If you run these scripts below this version, then it might throw out some errors about the tuple states or something like that. So you just make sure you upgrade the version of TensorFlow. Then in these scripts we're gonna use this batch data that generated by this function, and we're going to create the ASTM RNN, that is the ASTM cell. On the top and below the cell, we're going to create one hidden layer for inputs data and one hidden layers for the output data, same as the previous RNN tutorials in my series. And we just ignore this first. We're going to go through these steps. Okay, that is add input layer, add cell, and add output layer. This is what we're going to do today. And compute the cost, which we're gonna use the tf.nn, the sequence to sequence sequence lost by example. That is to compute the cost for every time steps, and this is just like a list of loss for every time step, and we gonna sum this up and divide by the batch size to get the average cost of this batch, just a single value for the average cost of this single batch. And then to use the mean square, this is mean square error. Just ignore that this is not mean square root, it's a mean square error of this prediction and target. And then same as before, weight variables to get the variable of weights and bias. And then we're going to create one animation about how the RNN learns to fit in the targets. So let me just show you this example, how the RNN fit into the line. Okay, this is the result of the day. We're going to create this one. So the red line is the sequence, the original sequence, and the blue dummy line is the RNN that learns to fit in the red sequence. So at the beginning, this one is just junk, and once the RNN learns something about the sequence, they're trying to fit in the red line, and at the end of learning, they fit the red line very well. So that is the result of today, and we're going to realize that. Okay, so we add input layer, that is layer in input layer X. So this is the X for input layer. We have to reshape this placeholder. This is a placeholder. Reshape this placeholder into 2D X. So the placeholder over here for X is a 3D 3D array. You can say this is array or tensor. This is 3D tensor. We have to reshape it to a 2D tensor in order to use just a moment, in order to use the wx plus b, this function, because w is a 2D tensor as well. So 2D times 2D, we can get the result, but 2D times 3D, that's nothing. So we get the weights variable by this shape and get the bias by this shape, and use the wx plus b. This is the calculation for the input layer, and we are going to reshape it back to 3D in order to input into the cell. So this is the output of layer 1 of the input layer. So we reshape the output over here to a 3D tensor. Then we can fit into this cell. So for the cell, we have defined, this is a LSTM cell with a forget bias as 1 at the beginning. State as tuple is 2. So you can check it out for my previous video about how I describe why we should use state as tuple and why we should use forget bias is 1. And this is the initial state is the 0 state, LSTM 0 state, and we're going to have a loop about the cell. The loop is dynamic RNN and use the LSTM cell and the output of this layer, and the initial state as this one, initial state, and time major is false because the time major is the second dimension over here. So that is the output and final states for the cell. Then we will use the output for the cell and becomes the input to the output layer. So the input of output layer is the every output for the cell for every time steps, because this is a sequence right now. It's not a prediction of one picture, so we're gonna use all output at once as the layer out X, and reshape this output to 2D tensor. And because we're going to multiply by the WS, which is also 2D tensor, and once we done that, this is the prediction of every time steps. This is the prediction of every time steps. It's not one time steps. And every batch, that is the prediction. And then we're gonna calculate the loss between the steps, between the prediction and the targets Y. We calculate for the loss for every steps and every batch for these two, and use the mean square error because by default the loss function is calculated by softmax. For this one is for the classification, but in here we use the mean square error. Just ignore the R for the moment. Ignore the R. Mean square error. This is the calculation method for the regressor. So just make sure you put this in here, and then just introduce this before. We just need to calculate what is the average cost in this total batch, and then pass this cost into these training steps. Minimize this cost. Okay, that is all, and we can now check it out in the Tensorboard. So we ignore all the following steps. Ignore that, and run this script for Tensorboard. Yeah, that is all done. So in here, this is my script for this file and for this code. So in the same local directory, we will have, this is for the testing, and this one is the file for the Tensorboard. So we have to use the terminal. Let's just terminal. No. Use the terminal and direct your directory into my local directory. Here is my desktop. So I just cd to my desktop. Okay, and in my desktop over here, I will run the Tensorboard. I just copy and paste, make it easy. Run the Tensorboard, and in the log folder, it has file for the Tensorboard. Then I just run it and view the results in my Tensorboard. Tensorboard is 0.0. The website of Tensorboard is your local website, and you can view the graph over here. This is what you create in this script. Just remove the trend step, and this is the structure. We have two hidden layer, in hidden layer and out hidden layer, and one STM cell. So once we open the in hidden layer, we can find out we have the WX plus B in here, and so we have to reshape the 3D tensor to 2D tensor, and once we done the calculation, just reshape it back to 3D tensor and pass it into the LSTM cell. And LSTM cell is the main structure over here is RNN. This is the main loop of RNN, and we have initial state, and we have output layer as well in here. Output layer is the WX plus B, and reshape into 2D and pass to this calculation, then to calculate the loss or cost. And one thing I have to mention is that, so in this website, hopefully I will remember to put the links in this in my description about this website. This website is introduced the backpropagation of RNN in TensorFlow style. So the normal backpropagation through time is something like this, but in TensorFlow style is something like this. So this is for one batch, calculation for one batch, and this is for another batch. So once we have done one batch, we will have one final state, which is also in here. We will have one final state. This is our final state in here, and we're going to use this final state and put the final state in the second batch as the initial state. That means that we have to, in the second run of batch calculation, we have to put this final state as the input as the initial states in here. So that is to say, in these following steps, in here, for the initial time steps I equals to 0, we just pass, for the feed dictionary, we just pass model X as sequence, model Y as result, that is get batch, and this X is the time point for all sequence and all results. We just ignore this by now. But for the first step in here, we don't create any states. But for the rest of steps, we use the state. This is the final state from last calculation, last step, and put the final state as the model initial state. So for the rest of steps, we do this for some purpose. So this state over here is the model cell final state, and we refer it as state. So we put this final state as the initial states for next run. So that is to say, we run the first batch, get the final state, and use the final state as the initial states for second batch. That is what we say in this script. So now we can run this script, and for every 20 steps we print out the cost, and this is for the Tensorboard, so I just comment out. That's okay. For every 20 steps we calculate the cost, so the cost is decreasing, that is good. Okay, and that is to say our model is good, nothing wrong. And we now can show you the animation over here. To show you animation, that is all these steps. In the beginning, we use PLT as the visualization tool, and set the IO, and that is to say that I can show and not block my main stream. So if you just ignore this step, the show will block the main stream, so you just stay in the plot. But if you use this one, just go and show, then go through all the steps behind that. So for every loop, every steps, we're gonna plot the time steps for in the batch, the time steps for this first example sequence and first result. This is the first result of that batch, and this is for the result we use the red color, and here this one is the prediction for the first example, in the batch, the first example in the batch, first sequence in the batch. So this is the prediction over here, and this is the real data in here, and we pause 0.3 seconds for every plot, and then we show that in here. So this is the final result. As you can see, at the first beginning, the blue one is just learns nothing, but with the learning procedure, the blue one is trying their best to predict the sequence of data. Okay, it's better and better right now. Learn something. How beautiful is that? Exciting? Yeah, I spent whole weeks to figure out what is happening in the code. Okay, that is all for today. Hope you will enjoy our tutorial series and hope you can learn something from it. And please subscribe and share this tutorial to your friends. That is my best wish. Bye.